Welcome back and let's prep for better jobs. Today I'm going over valid anagram. I'm first going to cover the definition of an anagram and then I'll go over the optimized solution and then I'll code this. Now there's a couple different ways to think about an anagram here. The first one is going to be looking at the lengths of the string. So we know that if these are a valid anagram, the length of string S must be equal to the length of string T. And the second way to compare these is if we know these are the same length already, we can sort string S and sort string T. And with these sorted, if S is equal to T, these are a valid anagram. And for the third way of checking these, we first want to check the length, and then we don't sort these. So instead of sorting these, we're going to use two hash maps. Then with both of our hash maps created, we want to build a frequency count in our maps. So it's going to be for string S, we iterate through this, and we count how many times character A appears, character N appears, and every single character in that map. We put that info into map S, and then we do the same thing and we iterate through string T and we take that info of the character counts and we put it into map T. And at the end of that process, we're going to get two hash maps that look like this, where the key is the character and the value is how many times that character appeared in the string. Now the time complexity for building these maps is going to be O of S plus T, where S is going to be the length of string S and T is the length of string T. Now the space is going to be actually O of 1. That is because the maximum size of map S is going to be 26 and same with map T. So since the space doesn't increase with the size of our inputs, it's actually just O of 1. All right, now at this point I can describe the solution. So what you're going to do is check the length of S and the length of T. If they are not equal to each other, you return false. Otherwise, you go to step 3 here, you build map S and you build map T. That's going to be done in O of S plus T time and constant space. Then after that, the last step is you check is map S equal to map T. And if you're using a language such as Python, what this will do is behind the scenes, it'll check each key value pair in S and T and check if they're exactly the same. And since we know that the maximum length of these maps is 26, this comparison is just constant time. So your final complexity for the solution is right here. All right, now let's get into coding this. First thing we do is we check if the length of S is not equal to the length of T, we return false. Now if these are the same lengths, we want to create our maps. So I'm going to do S count and T count, and I'm going to set them both to an empty dictionary. Then we want to go and increment these character counts. So I'm going to use the same variable I to iterate through this. Now since we know that these are both the same lengths, I can put down S or T here and it's going to be the same. Now I want to increment the character count. So I'm first going to do S. So we do S count of S of I is then equal to 1 plus the current count. So you can get the current count by doing scount.get, pass in the key here, so it's S of I, and then the 0. So what this does, if it can find the value for S of I, it returns that value. If it does not exist, it returns 0. This is a really standard syntax to use. I'm just going to paste in the same thing for T. Then at the end, we have both maps built, so we return scount is equal to T count. So let me run this. It's accepted. Now I'll submit it. Also accepted, and thanks for watching.